Welcome everyone. In this video, we will continue solving questions related to entropy topic. So here we have another question. Stop the video and have a look. So place one tick in each row of the table to show the sign of each entropy changes. So here we have the here we have NaCl dissolving in water, and is the change is entropy is negative or zero is positive. So we have NaCl, which is solid. We dissolve this one in water, so it will become Na plus Cl minus. So here we got ions. So the change in entropy will be positive, okay, because we have more disorder, we have more randomness because we have mobile ions. Water solidify to ice, يعني from H2O liquid to H2O solid. So guys, here we have less randomness. You know that water molecules can slide over each other, but in case of solid water, particles are strongly attracted to each other. No movement, so less randomness. That's why is negative. The change in delta S is negative. Let's move to the next question. This question, guys, these questions are in the same year, all of them. They came in a line. So the next question is a tricky question. Let's read together. The evaporation of 1 mole of water has a standard Gibbs free energy delta G of this. Okay. So we say that for 1 mole of water, delta G equal to 8.6 kilojoule per mole, whatever. This is, guys, the delta G at temperature of 25. Okay, sketch a graph on the axis to show how delta G changes for this process between 25 and between 150, the temperature. And here we have the delta G on y-axis. Here we have the temperature on x-axis. Before we start sketching, let me show you something, guys. Delta G equal to delta H minus T delta S. Look, guys, the process of changing water, H2O, from liquid state to H2O gaseous state, this process delta H must be positive, right? This part should be positive, is endothermic process. Minus T delta S. Delta S here, guys, is what? Think about it. We are moving from liquid to gas. That means the entropy change here, it is positive, right? The change in entropy, it is positive. So look, guys, this side is positive and this side will be always negative because this negative will be multiplied by positive sign here. This side is always negative. So for this process to be spontaneous, for delta G to be negative, what should we do? We should increase the temperature. So when we increase the temperature, the side, which is negative side, will be larger than this side, which is positive side. So we end up with negative sign. What I'm saying is, as we increase the temperature, what will happen is the delta G gets less positive or more negative. Okay? So according to this graph, at temperature of 25, which is here, okay, at temperature of 25, temperature of 25, let's say delta G was 8.6. So let's suppose that 8.6 is here. Okay, this is 8.6. As you increase the temperature, you will see that delta G gets less positive and more negative. It will be more spontaneous. We keep moving until we reach to 100. Okay, so guys, in the exam, you must use ruler, by the way. Yeah, at 100, your line must reach to 100 here. Okay, because you know, guys, at 100, water boils. Water change from liquid to gas. So any change in state has delta G of 0. It's equilibrium. Okay, so here we have the line and it keep moving and being negative. As you increase the temperature, the process will be more spontaneous. Delta G gets more or gets larger negative in number, larger negative number. Okay, to keep moving like this. So yeah, we finished the question, but it is, as I said, tricky question. Let's move to the next question. And this question, guys, the reaction between A, B feasible at low temperature, but is not feasible at high temperature. It is feasible at low temperature, but not at high temperature. We have this reaction. Deduce the sign of delta H and delta S of this reaction and explain why feasibility changes with temperature. Why feasibility changes with temperature. طيب. So look, guys, we know that delta G equal to delta H minus T delta S. Okay, minus T delta S. طيب. The reaction is feasible at low temperature. So here we know that delta H should be negative. Okay, and delta S, guys, in this scenario, delta S in this scenario will be negative as well. So I'm supposing that delta S is negative. So what will happen is this negative will be multiplied by this negative. This part, the whole part will be positive. And we will see why. I suppose this. So at low temperature, T is small. This T has a small value. So the whole part, which is the positive part, will be small. Okay, will not be a large value, small value. So the positive part will be small. The negative part is larger. That's why large number and negative plus positive number, it will be negative number. So delta G is spontaneous. But as you increase the temperature, the process will not be feasible, but the reaction is not feasible at high temperature. So if you increase this temperature, the reaction will not be feasible. That means this part will be large positive number and overcome the negative number here. So this part will be larger and positive, and delta G will be positive. Okay. So yeah, that's why delta S is negative and delta H is negative as well. So deduce the second part of the question, explain why the feasibility changes with temperature. So we say that as we increase the temperature, the feasibility of the reaction decreases because T delta S part will be or will have large positive number. Okay, so let's move to the next question. Here we have another question, guys. Have a look. So this compound is unstable and really decomposes when warmed. The decomposition reaction is shown here. It has delta H negative exothermic process. Use the data and table to calculate the entropy change delta S. So it's very simple. We say delta S equal to S of the products minus S of the reactants. S of the products, guys, in the products we have nitrogen, but we have half mole, okay? So 1 over 2 multiplied by the nitrogen, 192, plus we have oxygen as well, it is half multiplied by 205, plus we have half multiplied by I2, which is 261, plus H2O is only, we have two H2Os, so 2 times 70, minus the reactant, we have one thing, only one thing, a reactants, so it is minus 42. طيب, let's use the calculator to find the answer of this. This one will be, okay, half. طيب, yeah, this one, guys, is gonna be 427. Okay, so delta S here is positive because in the products we have gases. Yeah, it is 427, the delta S. Let's move to the next part of the question. This reaction is feasible at all temperatures. Explain why using F and Fi. So look, guys, why this reaction is feasible at all temperatures. Once more, delta G equal delta H minus T delta S. Delta H is negative. This one has a negative value. And T delta S, guys, will have negative value as well, because delta S is positive. So negative multiplied by positive, the whole part here will be negative. Okay, so no matter what the temperature is, the product of this process, the value that we get, it is always negative, so the reaction is always spontaneous. Okay, delta G will be always negative because the reaction is exothermic, and T delta S part will be always negative, will always have negative value. So delta G is always negative. This is how do we answer the question. Okay, guys, so let's move to the next question. Next question is here. So let's have a look. And this question, we have two equations or two reactions. This is reaction 1 and this is reaction 2. طيب. The standard entropy change for reaction 1, delta S for reaction 1 is this. Suggest with the reason how the standard entropy, how delta S for reaction 3 might compare with delta S for reaction 1. So we want to compare the delta S of this reaction with the delta S of this one. Guys, as you see here in reaction 1, we have aqueous compound reacting with CO2 to give us this. And here we have this compound reacting with two CO2s. Two CO2 molecules are being consumed in this case in here. Okay. So in reaction 3, 2 moles of CO2 are being consumed. Okay, 2 moles of CO2 are being converted to this product, 2 moles of CO2. But in this reaction, we have only 1 mole of CO2 is being converted to these products. So delta S of reaction 1 will be more positive. Okay, delta S of reaction 1 will be more positive than reaction 3. The reason is in reaction 3, there are more CO2 molecules, more gases molecules being consumed. Okay, so as we have more gases molecules consumed, this the delta S here is going to be more negative. So this is the reason. So let's move to the next question, but just let's do this like, yeah, make it larger. This is the next question. Yeah. So let's see. Some values for standard enthalpy change of formation delta H. Okay. And the entropy are given in this table. So we have delta HF and entropy values. So define the meaning of entropy. Before I gave you guys the definition of entropy in the previous video, so you can keep using this definition. It can be applied for all these questions. So let's see the next one. The next question says, calculate standard entropy change for this reaction. Once more, delta S. So just 1 second. Yeah, so let me close this. It's useless. Okay. Yeah, this is much better. So we are asked to calculate the delta S for this reaction. So let's calculate the delta S. It is S of the products minus S of the reactants. And by the way, the reaction is, just 1 second, let's write the reaction for this one. I wrote this somewhere. The reaction is NH3 plus NH2 Cl gives us HCl plus N2H4. طيب, so let's calculate to calculate the entropy as we see in the previous page. Then we say the S of the products minus S of the reactants. So delta S will be, in the products, guys, we have HCl. HCl is 187 plus, what do we have also on the products? N2H4, it is 237 minus the reactants. The reactants are NH3 ammonia, which is 198 plus, sorry, here we have a plus the N2H4, sorry, plus NH2Cl, which is 241. Here, guys, the answer will be, I think is my calculator. The answer is gonna be minus 15. Okay, it's gonna be minus 15. طيب. Let's move to the next part of the question. This question, this paper actually is from, I think from 2018 or 2017. So this topic of calculating delta H is excluded. You don't have to know this, but I will do it anyway. So we need to calculate delta H for this reaction. Guys, calculating delta H from what? Delta H of a reaction from delta H of formation. Okay, so calculating delta H of this reaction from delta H formation. So we know when we calculate delta HR from delta HF, we say delta H of products minus reactants. Okay, in this case, we don't have to draw the enthalpy cycle. So just products minus reactants. So in this scenario, we will say delta H equal to, in the products, we have HCl. Where is the HCl? Yeah, it is minus 92. Yeah, and we have N2H4, which is plus 95. طيب 0.4 minus the reactants. What we have in the reactants? We have in the reactants 298, right? Oh, sorry, no. Wait, we have 80.1 plus, or actually minus, because the sign of it is minus 45.9. Okay, so the value here will be minus 31.1. So this is, guys, exothermic process, but you don't have to know this anyway. Let's move to the next part of the question. Calculate delta G when the temperature is this. Okay, calculate delta G when the temperature is this. So we know that delta G, delta H minus T delta S. Delta G, guys, sorry, delta H, we calculated it. Now it is minus 31.1. طيب, minus T delta S. Temperature 298. And delta S we calculated, it was minus 15, right? طيب, we missed something, we forgot something. Guys, you know, delta S and delta H have different values, have different units. So to convert, you must multiply this one by 1000, the delta H, to convert it to joule, or divide this one by 1000 to convert it to kilojoule. So it's up to you. I'd rather multiply this one by 1000. Yeah, so this one, let's use our calculator. What will be, it is 31100 minus 28 times 15. Okay, so this one will be minus 31100. This one will be plus. Okay, it will be 26630, and yeah, this one positive, minus 31100. We missed something, I think. We missed something. Yeah, sorry guys, when we multiply these two numbers, we don't get this value. Sorry. We will get 298 times 15. We will get 4470. And after that, let's subtract them. We get minus 2663. Yeah. So guys, here the unit is joule per mole. Don't forget the units. Sorry, the unit. And you will multiply by 1000 to convert to kilojoule. So you end up with minus 26.6. We round it, and yeah, round down. Kilojoule per mole. طيب. The next part of the question, explain with the reference to delta G why this reaction becomes less feasible at higher temperature. At higher temperature, the reaction becomes less feasible. Guys, delta S here has a negative sign, okay, as we said. So when you increase the temperature, sorry, before this, yeah, delta S has negative sign. And when to multiply it by this, it will be positive. So T delta S part is positive, right? If you increase the temperature, the positive part will be larger. it will be greater, okay, than the delta H, which is negative. So if you keep the temperature and if you decrease the temperature, this part will be positive and it overcome the negative of this part. So the process will be non-spontaneous because delta G will be positive. Okay. So to answer this question, we can say, let me see. Yeah, we can say that at higher temperature, T delta S part will be more positive, okay? And it will overcome the delta H, the negative delta H. So delta G will be positive, and the process is endothermic. Sorry, the process is non-spontaneous. The reaction will not be feasible at higher temperature. So this is what we have for today. These are questions, and inshallah, I'll just post another video with more questions.